Hi, in this video I'm going to wire up the schematic. Now again, when you get to lab 7, all this will matter a lot more, but here we're going to wire up the DAC and the op amp, and so for depending on which DAC you have, you may have a different interface. So pin by pin, I'm going to look at SDI, that's obviously master out, slave in. So I'm going to tie master out, slave in, which is PD3 here to the the serial data in. All right. Next, I'll look at the clock. The clock is obviously the clock. That's going to be the synchronous serial clock. Synchronous serial clock is on PD0, so I'll tie it to PD0. All right. Next, I'll get these two are a little bit tricky, but if you look at the shape of chip select, that matches the frame select. So chip select on the DAC will connect up to frame select on the TM4C. All right, frame select is PD1. Click, 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 click. Okay, so I've hooked up. These are just regular GPIO pins. And I'm just going to wire them up, and then we'll worry about the functionality in software, which we don't have to write. Okay. The next is I am going to take the output of the DAC and connect it up to the op amp. So let's power things up next. Okay. Now, one of the easiest ways to power things up is to just do a what you call it, a copy paste. So I can go over here, okay, and take this guy right here. See this right here? And take this guy here, and I'm going to do a copy, okay? I'm going to do a copy, and then I'm going to go where my thing is and paste it there, okay? So copy. I'm going to have to power this one too and paste. Okay. I'm going to need a capacitor. Again, let's wire it up. That's VDD, so I'll hook it up VDD. Hook up VDD. Click, click. And then over here, the power goes to V plus VS. Oops, messy. See, click, click. Oh, I did it again. See, click, click. All right. I'm going to need a bypass capacitor. So again, I can choose from the part, or I can scroll down and just take one from here. Okay, so I'm going to again do a copy and take one of these 0.1 microfarad capacitors. I'm going to copy it and then put it up here, right there, and then do it again. Copy. I need one for over here. That'll be my bypass capacitor for the power line. Again, every chip has one, and so I wire it in. Yeah. Oops. Now, sometimes you got to get the the snap right. Okay, so if you can't connect something like that, you see I can't connect it. What that means is my snap isn't perfect. So I'm going to go view grid here, and then you can see I have a size of 0.1. I'll make it half of that, 0.05. Okay, and that'll make it. The problem happened when I did a copy paste. So now I'm going to be able to hit it. You see. Yes, and notice this is a warning, but I definitely do want to have that be the proper net. All right, so again, I'm going to click, connect. All right, I need that was power. Now I need ground. Okay, again, I could add a ground pin, but just so that I get all of them the same, I'm going to make sure I take a ground pin that is ground, and I'm going to bring it up here and duplicate it. All right, somewhere, where's my ground? That'll be over here, it'll be fine. Duplicate it again. Now this guy is going to go to that pin there, by the way. So I'll put it there. Okay, so now I'm going to wire up the ground. Click. 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 Escape. Z. Click. Click. Zoom in. Click. There we go. Wire this guy. Click. Click. Then I got to tie the other end of the capacitor to ground. Click. 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 The other end of this capacitor needs to go to ground. Click. Now this is going to be a dual op amp, so I won't have to hook them both up. I'll just get one of them. All right. Let's see, where am I going here? Okay, so, all right, so I've wired it up. Now, this is not Lab 5. We don't have a filter or anything. And so all I'm going to do here is I'm going to buffer it. Okay, going to buffer it. I don't want to do that. There we go. So that means I'm going to bring the output pin of this in the voltage follower mode to the input. And then I'm going to tie the input to the output, the minus input to the output. So that's the negative feedback. And then this bad boy goes to the output. So where's my output? Right there. You see it? Now I happened to, I wimped out and chose one of the DACs that didn't need a reference. Sorry. Some of you are going to have to need a reference. That's okay. You did the reference in lab. You did the reference in Lab 5. Hook it up just like Lab 5 if you need it. Okay. Up. Up. Okay. And we'll decide to use pin 1 as the signal and pin 2 of the connector to ground. So that's all I got to do. Now it turns out, like I said, in this particular guy, I don't need that one. I got to hit it. Where'd it go? Okay. So I don't need it. Okay. So in this particular case, I did not need. Because this DAC didn't require a reference. Now here I didn't hook them up. I don't care. All right. Move this over here. All right, so now the rest of this stuff, I guess analog output can go over here. All right, the rest of the stuff is simple things. Yeah, let's turn on the LED. I'm going to need a resistor for the LED. So pick a pin. I don't care. Again, I could choose a resistor from the library, or I can just take a resistor that's already there. Right. It's already there, and in fact, I'll take it from the power circuit because it's close enough. All right, so I'm going to grab this resistor here, and then I'm going to put it. I'm going to need two of them, one for the switch and one for the LED. All right, and I'm going to. Oh, I already got a ground. Okay, so I'm going to put a ground. Okay, so there. And I don't really care how bright you make your LED. Yeah, I could make it a little bit bright if I change it to 680. It'll be a little bit brighter. I don't care. We're not building it, so it doesn't really matter. I'm going to move the ground down here. Now, you'd actually, if you want, you don't even need. If you want, you don't even need the resistor for the switch. We can just say the software guys are going to do internal pull down. So yeah, why not? Why not? Why make it hard for ourselves? Okay, so I need a power line. Okay, for the switch up here, and I'm going to need a power line for the slide pod. All right. All right. See. Okay. Click. 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 I don't care what pin numbers you have, nobody cares, okay? The switch is going to be positive logic with internal pull down, okay? Now, I don't care, again, whether you connect both sides of the switch. I don't care. All right. Although I might have messed that up here. Let's move this up a little bit. No, yeah, okay. I guess it's... I made a mess here. I guess they're connected. We can tell by changing the nets. All right, let me keep building here. This guy is going to go to ground. I mean, this guy goes here. Again, this is lab, right? This is now lab 8 from 319K. So I just wired up the slide pot, and then this guy goes here, and this guy goes pick a pin. Your favorite analog input. Make sure you get an analog input pin. Okay. Yeah, where are we doing here? Mode, switch. Yeah, I'm done. Okay, so now the next phase. Okay, we'll look around, make sure I got everything. I didn't use port. Oh, I got to hook stuff up to the logic analyzer. All right, that's fine. So actually, what I'm going to do first is I'm going to change all the nets. Okay. Because these are crappy net names, and so I'm going to give them good net names. Okay? And I do that by adding a name. Okay, name, click, and I'm going to call it PD7. Now I could call it, if you wanted, I could call it clear or whatever it is, but PD7 is pretty straightforward. And I'll name, this is PD6. Again, I'll keeping along the theme here, PD 3, PD 1, PD 0. Okay, that's actually a requirement to make sure all the net names are wonderful. Okay, so we'll call this one V out. All right, and we'll call this analog out. So we're going to call this one DAC out. Not DAC out, analog out. I guess we could have called this one DAC out. All right, so now what I'm going to do, okay, I got some more. Let's finish all my net names. Over here, this one I'm going to call PE5. I'm going to call this one PE4. And I'm going to call this PE4. I'll call this one PE, what did I do? 2, I think. 2, right? 2. Perfect. There's one more net right in here. We're going to give it a name because, again, all our nets have to have names. And it's going to go LED voltage. I don't know. All right. Let's look around. Now, I haven't hooked up the logic analyzer yet, but I think I've gotten all the parts. All right, so now what I'm going to do is check all of my net names, okay? I'm going to check and make sure that's 3.3. I'm going to check and make sure this one is ground. I'm going to check to make sure this is analog out. I'm going to go through and check them all. The other way to check them all is to look in the design manager under nets, okay? If I look at nets under design and I show all nets. So one way to check the nets that I've connected everything up is to go into the design manager, click nets, click all sheets, net class, and now down in this window, I'll make it a little bit bigger, or not, okay, is the list of all my nets. And so ground is like everywhere, so that's not very interesting. And 3.3 is like everywhere. But VDD is only there. So again, I'm going to go through these one at a time and make sure they're all that I've got things what I think I've gotten. Okay, so there's T clock, there's TMS. These are the debugger signals. TO 3.7. Okay, so that's the net that has the switch 3.7 volts from the battery. Okay, here's the battery through the on-off switch through the current measurement. There's 3.7 volts. This net here is called switch power. There's the power to the LED, the reset pin. Again, you should look to see that everything that is connected should be, right? So there's the first oscillator, there's the other oscillator, the wake signal, the battery signal. Again, I'm going to click on these one at a time. PD3, PD0, PD1, PD6, PD7, V out, analog out, LED voltage, PE5, PE4, PE3, 2, and that's it. You notice I have no ends in there, okay? So I got no weirdness. Okay, so now all my nets are proper, okay? I can go over here and now wire up the logic analyzer, okay? So what I'm going to do is I'm going to make what looks like a dangling net, okay? I'm going to add a net that doesn't go anywhere. You see that? It doesn't go anywhere. Now, if I were to quit at this point, it would give me error because this is a dangling net. A net that's only connected on one spot. Nets basically have to connect to two spots. And again, the objective, the requirement here is to have 8 connections to the logic analyzer. Okay, so and I missed it. You see how I missed it right there? Escape. All right, and so some of these are obvious. I've connected up. If you go down here, you see I've connected up PD 76310. So I'm going to change the nets. All right, I'm going to change the nets of each of these. I'm going to change this to PD7. Now it's going to give me a warning that I'm connecting together, but yeah, that's what I want to do. Okay, I'll change this one to PD6. No problem. I'll change this one. Now I don't have PD5 and PD4, so I'll change this one to PD3. Change this one to PD1. And change this one to PD0. All right, now the other digital signals I have are my inputs and outputs. My switch, my PE5 and 4. Now I'm not going to connect to PE2 because that's analog. But over here I got 5 and 4. PE5. And PE4. Now I ran out of signals. So what I'm going to do is just, add some random one like PE3. Okay. Now at this point, PE3 is a dangling net. So I actually have to do the other side of PE3. So I go over to PE3 and make the other half, the other place for it to connect to. So again, I'm going to change its name to PE3. All right, so now I'm done. Okay, so again, I'm at the end here. I click here. I click the sheet. I do the. I look at the nets and I see I have no ends here. Okay, so I got no weird, stupid nets. All right, save. And now the output of the first part is a electric rule check, okay? And now some of these things are warnings. Okay, so there we go. That's actually a mistake, okay? That's a mistake. I don't want to clear that one, okay? Now some of these other ones, I don't care that the frame has no value, the jumpers have no value. I don't care. The LED has no value. The mode has no value. R4 having no value, that's another bug. Okay, that's a bug. Okay, and so the reset switch has no value. Okay, so I have two actual bugs. And this is interesting because it will tell me where it is, actually. Right? I double clicked it. And it showed that, remember, I made a mess here, and it really was a mess. Okay, so what I'm going to do is I'm going to break it apart and rewire it. Okay, so actually, whatever I did there was bad. Okay, so I'm going to fix it. Okay, click, 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 click. So that's a much better looking thing. The other one you saw was R4. So I could go over to parts, go down to R4. R4, where are you? R4, 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 where are you, R4? There's R5. There it is, R4. Okay, so that's a mistake, okay? I'm going to fix it. Now, between you and me, I don't care, but it is a 10K pot, okay? So I'm going to add its value, okay? All right, save again. Design rule, electric rule check. And now, again, I've got nothing left that's of value. So LEDs and jumpers and frames and switches don't need values. So I will approve them all. Okay. So I will approve all of these mistakes. Oh, okay. Approve. Okay. Approve. 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 All right. And now, since I approved those, I can now do the design rule check, and I got no errors. Okay, I'm done with the schematic. The next thing I'm going to do is placement, which is actually the most fun part of the design.